5-6 years in our CrossPats a few years ago at a video conference. I was giving a similar talk, but so when Dan came up with the idea of doing a talk,
don't have any more slides. Oh yeah, one more. Yeah, so one of the things that we've been able to leverage to get a lot of the data into our system is that we have integrations. You can see a lot of the company's logos here. if your logo is not here and you provide an API, you should talk to Binoy, who's sitting somewhere in the crowd. He's our product manager. He manages all partnerships. So we would love to have more people integrate with CALLSTATS. So if you have a platform or service, and that's with the end of the advertisements. Right, so quality of experience, right? That's what we sell. We say like everyone should have a good quality of experience or optimal quality of experience. If you're on a bad network, you should still be able to connect. You should be able to get some packets across, whatever those number of packets should be. So then the question is like, how do you measure all this? And there's so many things that you can measure. So this slide has been in every slide since the beginning. So the kudos to the Geek and Poke. They built this like in 2011, and it's been on every slide deck, including the fundraising slide decks. I raised like 4 million from the slide deck, so this thing is on point. So why is it important? Because like when we talk about real-time communication, it's different from the web. And even in the web, we're talking a lot about latency. And in real-time communication is even more important because it's not about high quality so much, it's about being able to be, you're able to see the person or hear the person in real time or near real time, like under 200 milliseconds, 300 milliseconds, 400 milliseconds. So there are like network metrics that you can be looking at. You can be looking at media pipeline metrics like, oh, I sent a frame, did it get rendered? Was it rendered in time? And so on and so forth. So you can build a quality model. And overall, what you want to present as customers or end users or service providers is annoyance. You want to know how many people are annoyed with the service at any given time, why are they annoyed with it, and then annoyance in itself is a definition that you need to find a meaning for, right? So like you as a service provider or app developer needs to figure out like what do you think is annoying your end users. So when we measure user experience, it's a thing, right? Like you have different components to it, and there are different reasons for each of these components. So for example, if you're an app like Hangouts or Meet Jitsi or something similar where you're in a call immediately as soon as the page loads, like you go to a URL and you're boom in a call, then that page load is very significant in that user experience because that's the beginning of it. But if you're something like Stride or a HipChat or like Slack, where you have this call to button where you click it, then that's another part of the context that you need to see, like it's the call init part. So that's like the first two steps. But then as soon as that happens, you need to like see how quickly the call sets up. And that's different. For example, what we've observed over the last 4 or 5 years is the fact that if you do call setup times on web can be super slow and people don't care about it, partly because you have multiple tabs, people go away, like go get a coffee. But if you're on a mobile phone, you press a button, you want that call to set up very quickly because you're totally engaged with that app at that point of time. You do not like switch contacts, you're going to wait for this call to be set up. So call setup times on mobile, we've seen need to be very, very short, like under 1 second, under a few seconds, just because you have the attention of the app, of the person, the end user. While on a desktop application, you have more leeway. We've seen like people wait for a call to set up for 15 seconds and they're there. They're not annoyed because they've not closed the tab, they've not done anything. It's still front and center. And we can see the long tail actually there. And then there's the whole call experience that you get onto a call, then you have this conversation, you see the other person, and if the call is short, the long calls, took, what was it, Debian? Whatever the first hop to Amazon from this end user would be, nearest Amazon data center. So we get some pre-tests. You might not be on Amazon, you might be on your own infrastructure, you might be on Google, you might be on something else. But at least it gives you one reference point to compare what happens during the call with. And then you can compare if that user complains about something, you have another data point, because if they go to this page and give you another set of results, you have like now 2 data points. So it's another thing that we built, keeping in mind the end users of a service. So that was a bunch of things that we did. So now some observations, because we have data and we always like to show graphs. So one thing that gets asked quite often, are we ready to do like high quality video? And whenever people talk about high quality video, they talk about being able to do audio video. They want to know like what are the bit rates that they can stream at. And you can see like this is audio, and in most cases 70% of the sessions are around this 40, 50 kilobits per second. So it's possible. There are few in some parts of the world doing sub 10 or sub 20 kilobits per second is a thing. Like they don't have that good connectivity. So using Opus at the lower end kind of helps, but now even there are optimizations in Opus that are being worked on to get it below 15 and 12 kilobits per second, so that it can actually address a lot of the concerns in the lower end of the market, where they want to do audio bit rates of about 8 kilobits per second. And we'll see how that goes. But in terms of what we observe, about 70% of the cases, you're good to do about 50, 60 kilobits per second. And then there's the video. And we can see, like, for example, there's a lot of people that end up doing the 500, 600 kilobits per second, about 40% of the cases. But the median bit rate is somewhere around the 1 megabit range. And the 2 graphs basically are 2 different quarters. So observing changes over time in different quarters. There's a lot of investigation going on in that. Why is it that way, like under 500 kilobits per second? Partly Chrome's start bit rate is 128 kilobits per second. They picked a random number and they put it in their code. That's where it starts. So if your call is short, then it'll bias towards that. The other thing is that if there are other issues in the network, then it might bias towards 128 kilobits per second. So I started the talk with talking about real time being round trip times, right? So for the rest of the talk, we're only going to look at round trip times, because that's what I love actually a lot. So overall, yeah, so there are different types of infrastructure. You do peer-to-peer, you do it with bridges, you have turn servers. So these graphs basically show it's a CDF of round trip times. The light blue one is for peer-to-peer. The gray one is turn servers, and the purple is bridges. And you're like, okay, you know, like at about, you put the line at 240 milliseconds, because that's what the ITUT said as guidance. Like 120 milliseconds one-way delay is really good, is decent quality of experience. So we said, okay, everyone knows that number. Let's draw a line at 240, and that's our like place where we will operate. And we noticed one interesting thing that, okay, bridges are slightly to the right, peer-to-peer is slightly to the left, but something happens with the turns servers. So they follow very closely to the peer-to-peer, and at about 50% mark, they kind of flip over towards the bridge side. And we were very amused by this observation about like half a year or a year ago. And we said, like, this is interesting because this is something that we had not thought about, because when we were plotting the bridge ones, it kind of is a smooth curve. The blue one is also very smooth, and then there's this gray one which is not. And we kind of know the gray one is turn servers, and turn servers are not as heavy as bridges, so people tend to put them all over the world. So we were like, if they're all over the world, why isn't it like smooth, like the blue one there? And why is there like it behaves peer-to-peer and then suddenly behaves like a bridge? That means like there's probably something going on here. And so we were like, okay, so this is happening, and what does our pre-call test tell us? Like, what do we see with that? So we said, okay, let's run the pre-call test. So the purple and the blue lines are our pre-call test for every call. And the yellow, orange ones are bridges and or turns and P2P. So in 90% of the cases, the P2P beats our turn servers, right, our pre-call test, which kind of makes sense because it's our infrastructure. It's not next to each other. Two people in the same country, like Germany or Italy, making a call to each other. It will probably go to like our infrastructure in Ireland, which is probably like the highest RTT they can get. So like peer-to-peer does better, but suddenly the turn servers for like everyone in the world that we monitor is like doing bad for about 70% of the cases. And we were like, okay, I think we kind of found the problem. Like the turn servers are not everywhere that our bridges are, our turn servers are. So turn servers for some people are in the bad place. And then we started investigating, is it only the turn servers or even the bridges? Because our assumption here was that, you know, the bridges were like just doing badly because like their infrastructure and they're supposed to be not in the same place as peer-to-peer. So like going slightly to the right is probably something we anticipate. But could it be as close to the gray one was another question. Like why isn't the blue, like why isn't the bridges as close to the gray ones? Like, is that a resource problem or is it like a cost problem? Is it just people being lazy? We don't know any of these answers, and we don't want to tell our customers like what we are seeing. So we want to tell them, but we're not sure what the problem is. So let's investigate more. And so we investigated more. And why is it important? Because one of the things that we noticed, we have our own metric called objective quality, which basically is red means bad, white means fair, green is excellent, and it's a 3-point scale, so 0 to 1, 1 to 2, 2 to 3 map to that. And we put all our customers, put all their qualities on a graph, and we plotted them. And we only made one distinction, if the participants were on the same continent or they were not on the same continent. And we noticed that, you know, like intercontinental means people are far away, the larger latencies, there's a lot of other networks in between, and you cannot control everything, as in you could not put fiber end to end between people, right? So like you have to trust other people's networks to do the right thing. So in a way you would get some kind of quality, and what we noticed here was basically that median quality for intracontinental is 1.5 and intercontinental 1.0. And we said, okay, let's assume the intercontinental is, we can't do anything because latency and routing, and we cannot influence routing. But why is the intracontinental, which we have a little bit more control of, is fair? Why isn't it like tending closer to 2? Why is it 1.5, smack in the middle? That means like there are things that are bad and there are things that are good, and then they kind of average out and you get something in the middle. And we were like not too happy with this, so we were like, let's work on this. So when I say infra now, I actually means turn servers, MCUs, SFUs, anything that is routing your media. And is it placed correctly or incorrectly was our question. The second thing is we try to use our own pre-call test to validate, because that's like a Doppler test. We see the RTT between the participants, and then we see the RTT with our infrastructure, and then we have like a point of comparison, the ground truth being our infrastructure compared to the other one. And the other question was, how big is the problem? Is it even worth investigating? And we already know like about 50 to 70% of the calls go peer-to-peer. But more and more people are deploying infrastructure for various reasons, either for circumventing NATs and firewalls, especially in enterprises where you might not have any other choice but to go through NATs and through a turn server, or through, because you want to do multi-party call, there are 3 or 4 or 5 people in a call. So how big is the problem? Where is it occurring? Number of sessions, hairpin. So these were the things that we were thinking about. So how big is the problem? So what we noticed was like 30% of the bridges in Asia and Oceania are wrongly placed. Like they're either in the US or in Europe. So someone in Australia, 2 people in Australia make a call and goes all over the world and comes back in. In some cases, it might be a financial or a business reason because you do not want to put infrastructure in every place. You might actually have to do it as far as Singapore anyway, because like Singapore is a hub, and you say like all of my Asian traffic is like Singapore and Hong Kong, and like Australia is so small traffic for us that Singapore is not a bad location. So we understand and we're cognizant of those things. 50% in South America was a number that I was surprised with. And then there was 10% background noise everywhere. So in the US we saw, or not US, North America we saw 10%, saw 10% in Europe. And that kind of also makes sense because there are things like you have Greece and you have Turkey, you have Israel, which is kind of confusing why it's in Europe, but whatever. And you end up putting infrastructure which is in Germany or in Ireland, so it will hairpin that far. Like you have very little control over those things. And then the other thing was Africa. Like we thought this would be really huge or big. And then we realized that we talked to some of our customers who were based there, and they said, yeah, we kind of know of the problem. So we actually do not put any infrastructure because people either want to make a call and it fails. It's probably better. They know that it's failed. They'll find another way of doing this. And it's probably better for them as end users, as service providers to know that the call failed and how big that problem is so that they can actually address it. And some people have gone and put infrastructure there. I have no idea how, but it seems like some people have managed to do that. And predominantly what we see is that it's peer-to-peer traffic there. So we were kind of surprised with this result. So now there are graphs. Taking a step back, when we look at a problem, we always want to like look at it in totality. So I'll step back again and say like, okay, we have this problem, and the first one I showed was a graph of RTTs across all media streams. We said, okay, let's take a step back and let's just see audio and video in comparison. Maybe it's just video being delayed, right? And that's what's causing all the RTTs to skew in one direction. And we're like, okay, let's do this. So let's start with audio and video, and let's see how the RTTs go, are shown here. So you can see like the audio and the video RTTs are more to the left, the audio RTTs are more to the right. There are more audio RTTs. That's kind of because we have some call centers and other operations where there are only audio-only sessions. So that's why you get a higher normalized count. But you kind of see the same shape for both audio and video, so not too bad. Then the other thing is, okay, let's see audio video when they're only intercontinental. So kind of, if 2 people are on a call and they're across geographies, like on two different continents or multiple continents, what do we observe? And we see something very nice, like we see Gaussian, and we love Gaussian, right? We understand how Gaussian works. And you can see like it's kind of to the right, you don't see anything at the lower end. 240, 250 milliseconds is where the RTTs show up, which is kind of similar as in if you make between Helsinki and San Francisco, the RTT is about 250, 260 milliseconds. So it kind of makes sense. It's like the results are validated. 2 people on 2 different continents are going to observe that kind of RTT. And that's distance question. So like distance contributes to RTT unless we can go faster than light. The other thing was, but if you're on the same continent, what do we see? And we observed this, and we were like, okay, the first half makes sense. Like this is the 240 millisecond line. Everything here looks good. But suddenly like there is this notch right here. And it's kind of similar to the previous one, the 250. So there's something happening here that like there's suddenly like something not on the right continent, like the bridge, because there are 2 people on the same continent, but maybe something somewhere else. So we're like, okay, notch shows up. That's always good. That means something bad is happening. And then we were like, okay, let's go one more step further. Let's take everyone who's on the same continent, intracontinental, and put all the audio video peer-to-peer on one graph, and put the others which were using a bridge or infrastructure. And you suddenly see that nice curve that we saw initially, like remanifestation of the overall curve that we see. Like we see very good RTTs for the peer-to-peer case, see bad, kind of like good RTTs, and then suddenly like another bad. So we see bimodality, which we can improve now, I think, because we kind of start to see a behavior that we were anticipating, which I was foreshadowing from the beginning of the talk, is that maybe the bridges are indeed in the wrong place. And so the last thing was intercontinental audio RTTs mapped. So we basically split this thing and we say, okay, now what does it look like? And you can see like the bridges are contributing to, the infrastructure is contributing to the higher RTT, which is like hairpinning. So maybe you're only a US-based infrastructure, and like there are people from Europe joining the call, and you're actually hairpinning two people in Europe getting their call to New York or to Virginia or wherever the infrastructure is based. And this kind of, we've seen this observation across continents. So to summarize, so this is summary. So this was like identifying a problem. We are trying to figure out how we can address this problem. So now you're aware of it. You guys should go and look back at your infrastructure and see if there are things that you can improve. Because then if you improve, then we'll probably see an improvement at our end already in these metrics. But summary, right? So WebRTC has been around for a while, 6 years now. We've been evolving the standards for a while. What we do notice is, so this is summary of what we observe. Chrome and derivatives, especially Electron or Opera, they dominate the ecosystem. They're moving very fast. Platforms tend to develop on top of it. The other thing that we notice is platforms. Desktop is the winner on, Windows is the winner on desktop, iOS on mobile. There's nothing new here, probably everyone knew that. The other thing that we notice is there's significant hairpinning in most services. While browsers and services are improving, this is something that the app developers and the platform providers and service operators can do themselves. They should look at this more closely. The other thing is we always present a summary of results. So what we've observed over the last few years is call setup failures. This has gone down significantly. It's been about 1-2% over the last year. There are things that, of course, break every now and then. Now that plan A, plan B, and unified plan is going to come, someone's going to deploy that, and some things will break. So there's always something, the standards are evolving. The other thing that we've noticed is setup time. I don't know how many people know the ICE, or the fact that Internet Connectivity Establishment Protocol exists, and Google's put a significant amount of effort in reducing the times between their ICE checks. So they went from 30, 40 milliseconds between ICE connectivity checks all the way down to 18, 20 milliseconds, which has contributed significantly to setup time. So now 70% of the sessions set up in half a second, which was really heartening for us because we were seeing a lot of numbers queue to 1 second or more. The other thing, we have this API where people give feedback, user feedback. So it's a 1 to 5 scale. Some people do 1 to 5. Some people do 1, 3, and 5. Some people just do 1 and 5. Like, unlike, I like, I do not like kind of situations. And what we notice is that most people, about 90% of them, find it score of 3 and 5 and above. The other thing, the other problem with this metric somewhat is because of kind of Uber, what I call the Uber's problem, because if you get into an Uber and you dislike the service and you give the driver a rating of 2, it asks you a bunch of questions that makes people give people 4 or 5 because like 2 or 3 has a social impact. A lot of people do not want to give people 2 or 3 on Uber unless they had a really bad experience because they also realize that drivers have a rating that they need to keep driving. So people tend to give like 4s and 3s. And what we see in our logs is also like people can be complaining vehemently inside the text box, like I do not like this, and I could not hear the person, and then they gave a scale of 4. And you're like, what? Like, why is this 4? Why is it not 1? Because people are just not very used to like giving these like really harsh scores anymore, it seems. So what we do observe is that, and there's no ground truth to that, right? We do not like go and read every message there is and see like if they're more unhappy than the rating that they give. So what we notice is that most people give 4s and 5s, about 90% of them, which is also in line with our objective quality score where it's about 80% of them are above 1. So on a score of 0 to 3, where 2 to 3 is excellent, 1 to 2 is fair, 0 to 1 is bad, we tend to get more like 1.5, 1.6 like I showed before. And that's kind of fair. And what we want, of course, is that more people move towards the 2 range so that we can go and improve our metric, because as long as things are bad, we can't really improve our metric, because like things are already bad, we can't make it even worse for our operators to say like, you get a 0 now, and like people like, we can't fix zeros. The other thing is average RTTs and losses. So of course, what we notice is that RTTs are lower for peer-to-peer compared to bridge. And peer-to-peer is 70 milliseconds, bridges are 140 milliseconds, losses, 95 percentile packet loss is low, 90% in the bridge case, 84% in P2P. So like pretty much like 90 or 84% of the calls have like little or no packet loss. When I say 95 percentile, means like 95% of the call duration had no like 0 packet loss, only 5% of it, and could have 100%. But it then becomes a question like how important is that 5% of that call? So that brings me to the last slide, which I'll close on, is Electron on desktop has really good quality, so tends to be like 2.0 compared to browsers, which are 1.5. I think a lot of it is because people who build on top of Electron tend to like take the user experience more seriously and try to accommodate Electron into like their whole process of user experience. And the fact that Electron does not change every 6 weeks. Browsers do change every 6 weeks, so that makes it like an arms race. And mobile is pretty consistent, 2.0. People tend to keep their qualities high on mobile. And as I said before, intracontinental, this is something that we are very interested in improving, because that's actionable. Intercontinental is a distance thing and routing thing that we'll tackle after we've tackled the intracontinental problem. So we want that 1.5 to 10 to 2, and that's like our mission for the rest of the year, to make sure that people, our customers, and in general, people know what they do with their infrastructure, where they place them, and if they're placing them in the correct place. So that's my last slide. Thank you.
Thanks, Varun. We've got no time for questions right now, but Varun will be around until Friday morning?
Yeah, Friday afternoon. I actually am in UK until Saturday.
Okay, so you've got plenty of time to go and talk to Varun.
Cool.
So right now is the workshops. So in here, we've got James Bodie's workshop on 4G cell site type things. And then in the other room, we've got Tim Panton and Dr. Lucy Rogers on robots with WebRTC or something like that. Just a quick heads up for the pub later on. You're not going to want to take your bags and things up to the pub, so go ditch your bags before you eat or something.